I've spent way too many hours bashing my head against the wall trying to effectively save my game when transitioning to a new scene. I tried using ChatGPT to help guide me, both 3 and 4, gave Google's Bard a try, and watched countless videos trying to find the clearest explanation that would translate to my game. Nothing was working. I just could not figure out how to easily save my game until I hit that subscribe button. No, but seriously, it was a lot of trial and error before I could get this working right, and I'd like to share my method here in case you might be trying to implement a similar feature in your game, or if you know something I don't, you can help me understand a better or more efficient method. Currently, what I was focused on saving was the player-made changes to the map. As of right now, the player is able to create plantable plots of land on the map with a tool. If the player has made a plantable tile, they are then able to place a seed on that tile and it will start the process of growing a plant. It wasn't too difficult to implement these features as I had already created an inventory system with a hotbar that tracks what item the player has selected as the active item, but obviously I wanted the player to be able to make the changes to the map, leave the scene to explore other aspects of the game, and return with the scene exactly how they left it, but making it so that the scene actually saved the player's changes in-game was much more difficult than I thought it would be. When the player approaches a door or anywhere that should change the current scene and presses the action button, that reusable instance of an entrance, which has the name of the scene we will be switching to, gets the name of the current scene and stores it in a global from-level variable to allow me to determine where in the next scene the player should spawn. It then runs a global function called saveSceneState and passes its own name to determine which scene should be loaded. Within the global script, I have two functions that do all of the saving and loading for scenes. Since I am only focused on saving this one test map scene right now, I have it hard-coded in to check if that scene is the scene I'm coming from. If it is, I create a new packed scene and assign it to the variable scene. Then I pack the current scene using scene.pack and grab the node that is the current scene. Finally, I use resourcesaver.save and pass in the scene I just packed, as well as the file name and location of where I want to save it. If I am not coming from the map I want to save, then I call the loadSceneState function and pass through the next scene I want to switch to. This way of saving will take the scene that is currently open and will save all of its children, allowing you to load it and set it as the current scene later. But it didn't work exactly as I expected. We'll explore that more after we cover the loadSceneState function. First, I assign the current scene open to the variable level, and then call removeChild on the root of our scene tree. This effectively closes the current scene. I then use callDeferredFree in order to free up the memory from that scene we closed. Next, since I am only concerned with loading the save file of the test map scene, I have hard-coded that in, but this will change in the future to save all scenes in a similar way. So, if the next scene is test map, I use resourceloader.load to load the previously saved file and assign that scene resource to the variable next level resource. If that is not null, meaning there is currently a save file with that name, then I instantiate that scene, add it as a child to the root of the scene tree, and set it as the current scene. If there is no save file with that name, then I load that scene fresh in its original condition. If the next scene was any other scene, then I load those scenes in their original condition as well. Now, this effectively works and does retain the plots of land that the player created, but it wasn't saving the plants the player planted. Every time I loaded the saved scene, the plants would disappear. I finally found out that when the plants were instantiated, when the player clicked on the plantable tile, they did not have their owner set to the current scene. This was a problem because the resource saver function was saving all of the children of that scene that had their owner set to the scene being saved. Once I found that out, it was a quick fix to just set the owner of the newly instantiated plant to the current scene whenever the player planted one. But this exposed another problem. If anyone watching has a better solution to this than I have found, please let me know in the comments, but what I have come up with seems to be working so far. When I call resourceloader.load and instantiate the loaded scene, it instantiates all of the children and assigns them all new node IDs. So I had to come up with a way to track all of the plants outside of the scene so that I could accurately depict where they were in their growth cycle. They originally determined how long they had been planted within their own script, but when the scene was loaded, it would rerun that script from the beginning, resetting all variables and effectively making those plants act as though they were just planted at the moment the scene was loaded. To solve this, I created a dictionary in the global script and added to that dictionary a key that is the exact coordinates of the tile where the plant was planted by the player. This location remains the same when the scene is loaded, so I could then assign some values to that key that will allow me to accurately depict the plant in its life cycle, like what day the plant was planted and what kind of plant it is. Now, when the scene loads, if that dictionary has the location the plant is planted in as a key, it will read the values associated with that plant, calculate how old it is, and therefore what frame of its life cycle should be depicted as, and all of this is done before the player can see the scene. This method will have to be used for all elements in the scene that change over time, so I can imagine this getting complicated as I add more features, but as of right now, this was the best solution I could come up with. I am really excited that I've been able to implement this feature into the game, as it lays the foundation for all other player-made changes to the map. The core of this game is heavily inspired by the game DarkCloud, and a significant element of the gameplay will be the player retrieving buildings, parts, and other elements from the dungeon maps to build out the town in the way the player sees fit, while also being driven by where the townspeople want their own houses to be placed in relation to other elements of the town. If you enjoyed this video or would like to follow the development of this game and help support my channel, please hit the subscribe button and like this video, as it will really help with the whole YouTube algorithm thing. Thanks for watching.